Hello guys and welcome back. What is a thermistor? A thermistor is a resistance thermometer or a resistor whose resistance is dependent on temperature. The term is a combination of thermal and resistor. It is made of metallic oxides pressed into a bead, disc, or cylindrical shape, and then encapsulated in impermeable material such as epoxy or glass. There are two types of thermistors: negative temperature coefficient (NTC) and positive temperature coefficient (TTC). With an NTC thermistor, when the temperature increases, resistance decreases. Conversely, when the temperature decreases, resistance increases. This type of thermistor is used the most. A PTC thermistor works a little bit differently. When temperature increases, the resistance increases, and when temperature decreases, resistance decreases. This type of thermistor is generally used as a fuse. Typically, a thermistor achieves high precision within a limited temperature range of about 50 degrees Celsius, around the target temperature. This range is dependent on the base resistance. The arrow by the T signifies that the resistance is variable based on temperature. Thermistors are easy to use, inexpensive, sturdy, and respond predictably to changes in temperature. While they do not work well with excessively hot or cold temperatures, they are the sensor of choice for applications that measure temperature at a desired base point. They are ideal when very precise temperatures are required. Some of the most common uses of thermistors are in digital thermometers, in cars to measure oil and coolant temperatures, and in household appliances such as ovens and refrigerators. But they are also found in almost any application that requires heating or coolant protection circuits for safe operation. For more sophisticated applications such as laser stabilization, detectors, optical blocks, and charge-coupled devices, the thermistor is built in. For example, a 10K ohm thermistor is the standard that is built into laser packages. So how does the thermistor read the temperature? The thermistors do not actually read anything. Instead, the resistance of the thermistor changes the temperature. How much the resistance changes depends on the type of material used in the thermistor. Unlike the sensors, thermistors are not linear, meaning that the point on a graph representing the relationship between the resistance and the temperature will not form a straight line. The location of the line and how much it changes it is determined by the construction of the thermistor. So what is the difference between a thermistor and other sensors? In addition to thermistors, there are several types of temperature sensors that are used. The most common are resistant temperature detectors, or RTDs, and integrated circuits, or ICs, such as LM335 and AD590 types. Which sensor works best for particular is based on many factors. So how does a thermistor work in a control system? The main use of thermistors is to measure the temperature of a device in a temperature control system. A thermistor is a small but important piece of a larger system. A temperature control monitors the temperature of the thermistor. It then tells a heater or cooler when to turn on or off. To maintain the temperature of the sensor. Which thermistor's resistance and bias current should be used? It depends. Thermistors are categorized by the amount of resistance measured at ambient temperature or room temperature, which is considered 25 degrees Celsius. The device whose temperature needs to be maintained has certain technical applications for optimum use, as determined by the manufacturer. This must be identified before selecting a sensor. Therefore, it is important to know the following. What are the maximum and minimum temperatures for the device? Thermistors are ideal when measuring a single point temperature that is within 50 degrees Celsius of ambient temperature. If the temperatures are excessively high or low, a thermistor will not work. While there are exceptions, most thermistors work best in the range between minus 55 degrees Celsius and plus 114 degrees Celsius. Since thermistors are not linear, meaning the temperature to resistance values plot on a graph is a curve rather than a straight line, the very high or very low temperatures do not get recorded correctly. For example, very small changes in the high temperatures will record negligible resistance changes, which won't translate into accurate voltage changes. What is the optimum resistor range? Dependent on the bias current from the controller, each thermistor has an optimum useful range, meaning the temperature range where small changes in temperature are accurately recorded. The Steinhardt-Hart equation is a model that was developed at a time when computers were not ubiquitous and most mathematical calculations were done using slide rules and other mathematical aids, such as transcendental function tables. The equation that was developed was a simple method for modeling thermistors' temperatures easily and more precisely. So who is Steinhardt-Hart? John S. Steinhardt and Stanley R. Hart first developed and published the Steinhardt-Hart equation in a paper called Calibration Curves for Thermistors in 1968 when they were researchers at Carnegie Institution of Washington. Steinhardt went on to become professor of geology and geophysics and marine studies at the University of Wisconsin-Madison, and Stanley R. Hart became a senior scientist at Woods Oceanographics Institution. Last but not least, thermistors are temperature-dependent resistors, change in resistance with changes in temperature. They are very sensitive and react to very small changes in temperature. They are best used when a specific temperature needs to be maintained and when monitoring temperatures within 50 degrees Celsius of ambient temperature. Thermistors, as part of a temperature control system, are the best way to measure and control heating and cooling of a Peltier device. The ability to adjust in minute increments allow the greatest overall system stability. Thermistors can be embedded in or surface mounted on the device needing temperature monitoring. Depending on type, they can measure liquid, gases, or solids. And that's it for thermistors today. Thank you guys for watching. Please like, share, subscribe, and always feel free to comment. Thank you guys and see you in the next one.